Applying polynomial operations to geometry. Here is a question where you have a shape, a rectangle, and the sides of the shape are represented by polynomials. In this case, we have a binomial to represent the base. It's 4x plus 3. And we have a binomial to represent the height, which is 4x minus 3. And now they're asking for the area. Remember, the area of a rectangle is base times height. Okay, so now we will replace the binomial expression for the base, 4x plus 3, and the binomial expression for the height, which is 4x minus 3. We can simplify this expression using the FOIL method. 4x times 4x is 16x squared, and then 4x times minus 3 minus 12x. 3 times 4x is plus 12x, and 3 times minus 3 is minus 9. Now you'll notice these middle terms cancel out, and we end up getting an expression for the area of 16x squared minus 9. Now what I want you to notice is that there is a shortcut. Now the shortcut is whenever you have conjugates. What are conjugates? Conjugates are when you have in your polynomials the same terms, except the only difference is a plus and a minus. So in this case we have 4x plus 3 and 4x minus 3. So just remember that anytime you have a plus b times a minus b conjugates, then you can quickly simplify and say it's just the a squared minus the b squared, and that middle term will drop out. So our particular example here, we have conjugates 4x plus 3 and 4x minus 3. So the shortcut would say that's 16x squared, that's the first term squared, minus the second term squared. 3 squared is 9. Same thing. So you can either do it the long way using the FOIL method, or you can remember the shortcut. Here is another example. This time we have a square. Now if you remember, a square has both sides, or all sides are equal. So if the bottom polynomial is 6y minus 5, then the polynomial representing the sides is also 6y minus 5. Again, they ask for area. So area of a square is side squared, but you can just think about it as a rectangle. It's a special kind of rectangle, base times height. In this case, the base and the height are exactly the same. So we will write our polynomials, 6y minus 5, and again times 6y minus 5. So like usual, we could simplify using the FOIL method, where we multiply each term by each term. In this case, we would get 6y times 6y is 36y squared. And then we would get 6y times minus 5 is minus 30y. Then minus 5 times 6y, minus 30y again. And then lastly, minus 5 times minus 5 is plus 25. Now, as usual, we can combine like terms for the middle two terms, and we would get an area expression of 36y squared minus 60y plus 25 for the area of this square. Now again, there is a shortcut. If you notice that both binomials that you are multiplying when calculating the area are the same, this is called squaring a binomial. And there is a shortcut for that, which says you don't have to do the whole FOIL and multiply it out. In this case, for example, 6y minus 5 times 6y minus 5 is the same thing as just saying 6y minus 5 squared. Now don't make the mistake of thinking, oh, that's just 36y squared minus 25. You can't do it that way, but what the shortcut rule says is that you square the first term, you square the last term, and then for the middle term, you just multiply 2 times the first term times the last term. Okay, now we can go ahead and simplify, and we would get 36y squared plus 2 times 6 minus 5. All of that multiplied together is not plus, it is minus 60y, and then minus 5 squared is plus 25. If you notice, that's exactly the same answer that we got when we did it the long way. So you have the option to either do it the long way or do it the shortcut way. Okay, one more example. We'll do a little bit more of a challenging example. Has to do with the volume. So just a reminder for those of you who don't remember your geometry formulas very well, when you have a cube that's like a square and then in 3 dimensions, so all the sides are equal, that the equation for the volume of a cube is just side cubed. Okay, so in this case, it's just going to be x plus 3 times x plus 3 times x plus 3. I'm going to go ahead and use the shortcut method just to save us some time. I will do this binomial squared first. So remember, that's just x plus 3 squared. We'll do this other dimension last. Okay? So x plus 3 squared, the shortcut method, says we do the first term squared, and then the last term squared, and then twice the first and the second term. So this will simplify to be x squared plus 6x plus 9 as a shortcut, and then times x plus 3. So now we have to go ahead and multiply each term here. So we will get x cubed plus 6x squared plus 9x, and then these multiplications, 1, 2, and 3, we will get 3x squared plus 18x plus 27. Our last step in the volume would be to combine like terms. So x cubed, 6x squared plus 3x squared is 9x squared. 9x plus 18x is 27x. And then plus 27 as our last term. That's a little bit more of a challenging volume problem, but it's a common way they ask, they combine polynomial multiplication problems with geometry.